Hello good people, I'm going to start talking about this wonderful thing called stoichiometry. The word comes from Greek. Stoichion means element and metron means measure. In general terms, stoichiometry deals with the quantitative relationship between reactants and products. When we talk about a quantitative measure, we are essentially answering the question of how much of stuff or matter do we have. As it so happens, this quantitative relationship between reactants and products is all about ratios. Allow me a bit of a side story. Baking is also all about ratios. If I want to make some bread, I will need flour and I will need water. However, if I want to end up with a loaf of bread rather than just a mess, the ratio between flour and water has to be correct. And for most types of bread, that ratio is 2 parts flour and 1 part water. If I want to make a bigger bread, or let's say 2 loaves of bread, I would need to double the amount of my ingredients. And so I would need 4 parts flour, 2 parts water, and that will result in 2 loaves of bread. There are 2 very important things to note here. The first one is that whatever happened to one component had to happen to all of the other components of this ratio system. I wanted to end up with 2 loaves of bread, in other words, I have doubled the amount of bread, and therefore I needed to double the amount of water and the amount of flour. The second thing to note is that the ratio relationship has remained the same. And so in this case, I could say that the stoichiometric relationship or the stoichiometric ratio is 2 parts flour, 1 part water to give 1 loaf of bread. Or to keep it very simple, I could say that the ratio is 2 is to 1 is to 1. How does this relate to chemistry? Here we have molecular hydrogen reacting with molecular oxygen to give water. There are 2 oxygen atoms on the left-hand side, so I'm going to place a 2 in front of the water molecule. This way, I have 2 oxygen atoms on the right-hand side as well. However, by placing this 2, I have changed the number of hydrogen atoms. Right now, I have 4 hydrogen atoms on the product side and only 2 on the reactant side. I'm going to place a 2 in front of molecular hydrogen, and now everything is balanced. Once we have balanced a chemical reaction equation, we have also obtained its reaction ratio. And in this case, it would be 2 molecules of molecular hydrogen, 1 molecule of molecular oxygen will give 2 molecules of water. The reaction ratio is 2 is to 1 is to 2. What if I wanted to end up with 10 molecules of water? How many molecules of hydrogen and oxygen would I need? Well, with respect to the original reaction ratio, I have increased the amount of water molecules 5-fold. Remember, whatever happens to one component has to happen to the other components. So if I have multiplied the water molecules by 5, everything else needs to be multiplied by 5. And so I will need 10 molecules of hydrogen and 5 molecules of oxygen to give me 10 molecules of water. Yes, I have changed the amount of reactants and products, but I have changed it in equal measure. The reaction ratio of 2 is to 1 is to 2 is the same as the reaction ratio of 10 is to 5 is to 10. And so I could say that the stoichiometric ratio for this particular chemical reaction is 2 is to 1 is to 2. There is more to stoichiometry than this, but understanding that stoichiometry depends on reaction ratios is a very good start. Before I sign off, I want to foreshadow some things. Atoms and molecules are very, very small. I cannot actually measure out 2 molecules of hydrogen and 1 molecule of oxygen. And at this stage you might say, fair enough, but when it comes to baking, we are not exactly measuring 2 grains of flour and 1 drop of water either. We talk about cups, we talk about bulk. In chemistry, from a certain point of view, we use cups as well. So I can measure out 2 cups of hydrogen, 1 cup of oxygen, and that will give me 2 cups of water. And in chemistry, that cup, that measure, has a special term, a special name, and it is known as the mole. To find out how the concept of mole fits into all of this, well, you will just have to stick around. That is all for now, and I will see you on the flip side.